Welcome back again, dear friends and viewers. So we're back in SolidWorks, obviously. Let's make a shaft. Yay! Right, so we're going to make the input shaft. Now, I wrote down the basic dimensions that I need for my shaft, and here they are. So we're dealing with the input shaft. So here we go, input shaft. So I've got diameter, length. So input stub, front bearing, gear segment, diameter and length, rear bearing, diameter and length. So the lengths of the stubs where the bearings go, that's arbitrary at the moment. Depends on exactly which bearing you end up selecting. So I've just put material there that is enough to do the job. Okay, so let's start building a shaft. Now, what you don't want to do is to draw circles and extrude them. That is not the best way to do a shaft by a long shot. Okay, what you really want to do is to draw the profile and then revolve it. Actually, it's half the profile. And we're going to revolve it around a center line, around an axis. So let's do that. So we're in our part file. We're creating a part with one of my custom part templates. So the first thing we need to do is to sketch. And we're going to sketch on a plane. So the right plane. We're going to drop a center line from the origin and out. Hopefully get that to lock horizontal, something like that. There we go. That's what we're going to revolve our profile around. Now, this is the origin. That's the part origin. So we need to be careful about where that part origin is along the shaft. And the best place to place it really is to think about where the gearbox is going to split. So it's going to split somewhere in the middle of the gear segment. But realistically, you want to try to set this origin up where all the components all line up with each other. So it could be where the in the center of the gear segment or on one end of the gear segment, but it definitely doesn't want to be on the end of the input stub. So it's kind of like sits between where one of the bearings sits and the gear, but you know, that'll be obvious in a minute once I've explained it. So first we need to do is to just run a line like so across that origin. Now we can go up. We're just going up an arbitrary value, and we'll set the real values later. So we need an input stub, so that's going to be my input stub, then a bearing, and then we've got the gear segment, and trying not to lock on horizontally to another feature. And this is going to be the back bearing stub. There we go. So there's my basic sketch. Now realistically I want this to line up with my origin, because that is where the bearing is going to sit, the input bearing. This would be the bearing on the back end of the shaft. This would be the input stub, and this is where the gear is going to go. So let's line all this stuff up. You could of course go with the middle section here lined up with the origin, and that might be better. In fact, let's do that. So we're going to go add relations. No, we're not. We're going to add a center line first of all. We're going to go straight up. We're going to drop it on the midpoint of there. Then we just make this vertical. There we go. So this center line here is coincident with the midpoint of that line and the origin. So that segment there where the gear is going to sit is going to be centered around the origin. Nothing else you can say about that. That's perfect. Okay. Now what you really want to do is to set all your diameters. So we know that my rear bearing needs to be a 12mm diameter. So that's from here to here will be a radius, but once we come down a bit further, that's going to be a diameter. So we'll set that to 12. There we go. It's set to 12. We can then click on all the other lines that are horizontal and it will create it will create diameters. And we're going to set this input stub to be 11. This bearing diameter to also be 12. And this gear segment to be 14. Here we go. That's easy, isn't it? Okay. Then obviously the whole thing is going to revolve about this line, but it's still blue on there. Obviously, because those blue lines haven't been located relative to the origin in any way yet. So let's build up the lengths of each of those segments. So I just hit escape there after I'd placed that so that it would drop the lock with the center line. So I'm going to set the width of my gear segment. That's 30. There we go. I'm going to set the width of my bearing segment, currently 12. Set the width of the other bearing segment. That needs to be 12 as well. So there's only one left to do, hopefully. Now I could set the length of this stub, but if I change these bearings, if I change the sizes of these bearings, it's going to move this face. So I need this distance from this end face actually to be measured from the center rather than this stub. That's a much more robust way of designing this element. And we're going to set this to, oh crikey, I wanted it to be 30 for this segment that's stuck out, but obviously I'm doing it from over here, aren't I? So we're going to have 30 plus 12 plus 15. Okay, so you can do the maths. 42 plus 15 is 57. There we go. So there's my 57 segments. So this bit here is 30, isn't it? That's all my dimensions done. So now what I want to do is to revolve that. So features, revolve boss or base. Now it's got two center lines there, so it's confused as to which one it needs to revolve around. So I need to tell it which one. This one. And I click OK. Now there's my shaft. But I haven't finished yet. I need to drop a keyway in there to lock the shaft to the gear when it's in operation, because although it's going to be a press fit, the amount of torque that you've got on there, it can sometimes overcome that press fit, especially if the temperature, if you've got a temperature change during operation, it can become loose and it can work its way down the shaft and off the end. So I'm going to show you how to do that in the next episode.